If you have ever worked with Excel files in the data world, you know the pain. Excel is everywhere. Every business, every domain, every team uses Excel to track data. But when it comes to Snowflake, there is a catch. You can't load .xls files directly. You have to convert them to CSV, upload them to a stage, and then load them into a table. Sounds familiar, right? In this video, I will show you how I tackled a common challenge, loading Excel files directly into a Snowflake stage without converting them to a CSV. With a bit of automation, the data then flows straight into a Snowflake table, eliminating those extra steps and saving a ton of time. If you would love to learn this automation, stick around. It could save your team's hours of manual effort every day. Before we proceed, a quick note. All the hands-on exercises are done using Snowflake's free trial version hosted on AWS with the Enterprise Edition. I recommend watching this video in 4K resolution, and if you are a fast learner, consider speeding up the video to 1.25x or 1.5x. If you want to take your Snowflake learning to the next level, check out my Udemy courses. So, let's start with a sample employee table and an employee dataset stored in Excel file. For simplicity, we will use just 10 records with a handful of columns. The objective is to create a stage location, upload this Excel file to a stage, then develop a Python-based stored procedure that automatically picks the file from the stage location and load into the target Snowflake table. Later, we will also load a larger dataset to observe how the stored procedure performs. Additionally, we will explore what happens when errors or exception occurs during its execution. So let's jump to our Snowsite web UI. So here I am in my Snowsite web UI and I have a couple of worksheets already open. So let's quickly switch our context and select our virtual warehouse. And let's create a database called Excel_DB, and we are going to use the public schema. So I can see my context is set and this is the role which I am operating with. I'm going to create an employee table and the field of the employee table matches with our Excel dataset. So it is created successfully. Now let me quickly check if I have any dataset available or not. So my table is empty. Now let's quickly create a stage location called my_stg. So we got this stage location created. Now let's upload that employee Excel data into this stage location. So I can always go to the database. So this is my stage location under ExcelDB, public schema, and my stage. Now let me quickly enable the directory table. Now I can click on this files and drag drop my employee.xls file, which has only 10 record. Now let me show you the name of the sheet here is employee and it has a total 10 column, primarily matches with this DDL. So I drag drop this employee-data.xls file, which is 5.7 KB, and I can click on this upload button. Now my file got uploaded successfully. Now let's go back to our worksheet. I can run list my stage location. This is the XLS file and the size is 5808 and this is the MD file. Looks good. So now I have loaded the Excel file directly into my stage location. So in the next step, we are going to create a skeleton for a stored procedure which wraps a Python code. So let's go to this another worksheet. Now let's understand what's happening here. So this is my create or replace procedure, which is a standard construct. And then I have given the name of this stored procedure as sp_load_excel2 table. It is expecting the file path. This is the stage location name and the sheet name and the table name on which this data would be loaded. And it returns a string. And here my language is Python. And the runtime environment for the Python is 3.9. Since I am using Snowpark, I have included this package called Snowflake-Snowpark-Python. And this is the handler. And this handler matches with the name of the function which will be invoked. And this is my double dollar sign, which is a standard approach to wrap your Python code. But let me uncomment for a moment. Now the color coding is enabled. So if you look into this stored procedure input parameter, this exactly matches with this parameter. Every time you call the function, which is a handler function, you need to make sure that you have to provide this session variable, which is nothing but your Snowpark session variable, and you can directly interact with Snowflake object, the table, view, stored procedure, or a function within that Python code. Now, before I really write a core logic, what I have done in the line number 90 and line number 25 onwards, it checks whether we are passing the right fully qualified table name or not. If the fully qualified table name is not provided, it returns a message. You can also choose to throw an exception. But for a simplicity, I'm just returning a string value, and it checks whether this table exists or not. If this table exists, good. If not, again, it says this table doesn't exist. And in this space, we are going to write our Excel code. Since your Excel could be small or a big, and it may eat up a lot of compute, all the input parameters are first validated. And once it is validated, then it will pick the Excel file and put it inside the Snowflake table. So let's create this stored procedure and see whether it is running or not. So let me undo this, and I am going to run this stored procedure. So my procedure got executed, and so when I'm going to call this stored procedure, I have to use this keyword call followed by name of the stored procedure. Since my context is already set, I don't need to provide a fully qualified. If your context is not set, probably you have to give the fully qualified name. And then if I have to pass name of the XLS file, I cannot simply say @tmp followed by the name of the XLS file. Since it is a file inside your Snowflake, Snowflake provide a function called build scope file URL, where you provide the name of the stage location and the name of the file. And you can also use a select statement to see what is the value. But anyhow, when we run it, it will print that value later as this particular variable. And this is the name of the sheet into the Excel file. And this is the table on which the data would be populated. So let me change this name. Now, first, I want to make sure my basic Python function is working. Simple validations are not. Once this Python code is working well, then I would embed the Excel related logic. So here you can see that my Python stored procedure is functioning appropriately. And let's check it if I give incorrect name. If I say 01, let's see what happens. So it says the particular table does not exist, which makes sense. Okay. Or if I give the name, but I have not given the fully qualified name, let's see what happens. It says that table must be a fully qualified as database.schema.table name. Looks good. So my Python stored procedure is functioning appropriately, and I can add more and more validations as needed. So now in the next step, I am going to add specific logic which will read the XLS data and insert into the employee data. This is my another worksheet called 03 Python SP, and let me quickly change the context. So the statement got executed, so context got changed. Now, if you look into line number 9, here I have added another package called OpenPyXL. This is a native Python library which can interact with the Excel file. It can read and write into the Excel file. So as you add this package, you also have to import the load workbook. This is the first step to incorporate this OpenPyXL package. Now, up to line number 30, we have already executed. Now, this is the piece of code which we need to understand. So, if you look into this line number 33, here I am using Snowflake file.open. This is a new library which I have imported, and this is part of your Snowpark library. So, you have to specify the name of the stage location, and this stage location should be a fully qualified stage location name and not just a string. Then you can use this load workbook library and get the access to the workbook. And from here, you will see if the workbook has a sheet name or not. If it does not have a sheet name, it will raise an error, and we will simulate that. What if I provide a different worksheet name? How does it behave? And then you get the access to the worksheet. Once you get the access to the worksheet, using this worksheet, you can get all the rows from that worksheet into a rows object, iterate and check if the rows object is having more than two rows, because I am considering that first row is a header followed by a data row. It should have more than one entry. And once you have this one entry, you can always fetch the header, and you can also get the data the way it is shown on line number 47 and 48. Now, we have to construct a schema, and that is schema will come from your header object. And once you have that, you can really create a data frame from that data as well as the schema object, and then simply write the data into your Snowflake table. So that simple is particular stored procedure using the Python library, which includes two packages, your Snowpark package as well as your OpenPy Excel package. Now, let me use a dollar notation to wrap this entire Python code and create this stored procedure once again. So this got compiled and successfully created. Now, here I am calling this stored procedure by passing the same parameter, and let's see what happens. Before that, let me check if I have any dataset available in my employee table or not. Table is empty. So it clearly says that data has been successfully inserted. And now let's run this select statement. So I can see total 10 record is available as we have seen into our Excel file. Looks good. Now let me make a minor changes, and let's say if I give this name to capital employee, and let me download this. Now let me bring that data here. So this is my version 2, exactly same size. Let me copy this. Now if I run, let's see what happens. If you look into this line number 37, 38, and 39, this block is checking if there is any sheet in this entire Excel file. If not, it says the workbook is not found. So it says that it raises a value error saying that this particular sheet is not found in the workbook. Okay. So it is expecting employee, but I have given employee, but E is capitalized. So your worksheet name is a case sensitive, and make sure that your worksheet has, you specify a right worksheet name when you are trying to build this logic. So if I just change this name to E, and let's see what happens. Since it is the same data set, it will duplicate the record, but it's okay. So now my data got populated, and if I run my select statement, it will have total 20 records. Okay, so I can see I have a total 20 record. Looks good. And if I go to the query history, you will see a lot of Python related entries here, and I'm not going to explain all those things here. We have already covered this stuff in a different video. And if you click on the telemetry, right now the telemetry is not switched on here. I will show you later how the telemetry looks like. But if you do not know how to use the telemetry, I would request you to go and watch this entire playlist, which help you to understand how to enable traces and logs and understand how the telemetry works, specifically when you're working on a Python based programming language within Snowflake. So since our data is getting loaded, let's try to load the data which is of 100K size and 1 million, and see how much time does it take to load the data. Now, I am going to load two additional files, and this file will have a same employee structure. However, the number of records in each file will be 100K and 1000K, which is equal to 1 million. So let me quickly load the dataset. So first, I am loading 100K.xls file of 7.4 MB. So it loaded pretty quickly. Let me pick another one. And this file is having 1 million employees, size 74.5 MB. And you can see how fast this gets loaded. So This also got loaded very fast. Now I have created two different worksheets, one called 100K, another called 1 million. I'm going to create a new employee table called employee underscore 100K and having the similar structure. This got created successfully. And since I loaded the employee underscore 100K XLS file in the same stage location, and this time I am using employee as a capital E because that is what the name of the sheet. And my primary purpose to invoke this stored procedure to see how much time it takes to load this entire data set. So it is almost 50 plus second. The data is not yet loaded. So if you see around 53 seconds, the entire data set got loaded. Now I can see I have total 100K record and all the data set is available here. So you can imagine that if you have 100K, 200K, 300K record, you simply load that big XLS file into the stage location and bring it on your Snowflake and you can start analyzing the data set very quickly, right? So this is the power of this automation. Now let me try this 1 million record and let's see how much time does it take. So first I'm going to create this employee underscore 1000K employee table. So this got created successfully. Let me call the same stored procedure by passing this employees underscore 1000k.xls and this is my worksheet name. Since it is 10 times more record, I assume it would take more time from the previous one. So it is almost a minute and I think I will wait for a few more seconds to see if it gets completed or not. So if you see it is 3 plus minute. So we loaded 100K record in close to 53 seconds. And now the data set is 10 times more. Whether it will take close to 5 minutes or not, I don't know. But let's see. So it took 7 minutes 46 seconds to complete this job, which is quite a so good amount of time to load the million record. Let's run the select statement and see whether I can see all the records. So I have the data available. So data got loaded successfully. And if I come to this particular tables screen, I can see my employee table, employee 100K and employee 1000K. And if you look into the data size, the 100K data is around 4 MB, which was actually 7.5 MB. And here the 75 MB is compressed to 27.3 MB. This data is 10 times of this data. However, Snowflake compression is very, very efficient. And that's why that entire 70 plus MB compressed to 23. So if I click on the query ID, let's see how does it look like. So here it clearly says that it has read 75.48 MB of data from external file location. So this is how the query profile looks like. If I click on query telemetry, this is still empty. It does not have any detail. However, if you would like to know how to enable the telemetry, you can watch this entire playlist. And let me show you if I enable the telemetry, how does it look like. So this is another run which I had it previously. And if you look into my telemetry, where telemetry is already enabled, this is how this telemetry information looks like on to the Snowflake. If I click on this collect, it will show you a lot of information related to what's happening on the Python code. Okay. However, the primary purpose of this video is not to focus on that. But if you are building a complex solution using Python, telemetry is a very, very important component which is provided by Snowflake. In this hands-on tutorial, we used Snowpark along with OpenPyXL library to load Excel data into Snowflake tables quickly and without any manual data wrangling. And if you refer this diagram, we eliminated step 1 and step 3 completely. And only with step 2, you are able to achieve the Excel data gets loaded into a Snowflake table. It's a solid starting point. But I know what you are probably thinking right now. This is great. But what if I want to fully automate the whole thing? I don't even want to upload the Excel to stage manually every time. Or maybe you are wondering, can I make it smart enough to create a table on its own just by reading the Excel header? What if the file has multiple tabs? Or what if you need to pick up Excel files from S3 location or Azure ADLS Gen 2 location or even FTP, or maybe you are getting them as attachment in email box? And what happens when your data comes in as a zip file containing dozens of Excel files, each with multiple worksheet? That's where thing gets really interesting. I'm working on a full course that goes deep into these real world use cases, covering advanced automation, tricky edge cases, everything you would need to handle this in an enterprise setup. If you're watching this video a bit later, the course might already be live. So check the description below, or if you're serious and want early access or just have a questions, have a comment or send me a direct message on Instagram. Hope you got something valuable from this video. If you did, please hit the like button, and this will help others to discover the relevant Snowflake video tutorial. And if you think this can help someone in your team, feel free to share. Thanks for watching and happy learning.